An explicit formula allows you to find any term of a sequence by using a formula written in terms of n. So writing the explicit formula for arithmetic sequences, here is the formula for the nth term of an arithmetic sequence. It's a sub n is equal to a sub 1 plus the difference of n and 1 times d, where n is a positive integer. And so to find the nth term of an arithmetic sequence, we have our a sub 1 is given as 12, and our common difference is given as 5. And we're asked to write the explicit formula for arithmetic sequences. So what we do is we start with the formula for the nth term, and we substitute in a sub 1 and the common difference, and we simplify. So that's what we're doing here. We're starting with the formula for the nth term of an arithmetic sequence. We're substituting in 12 for a1 and 5 for d, and we're simplifying, and what we're left with is the explicit formula that will give you any term n. So how do we do it for geometric sequences? How do we write the explicit formula for geometric sequences? Well, in lesson 7.7, we are given the formula. It's a sub n is equal to a sub 1 times r to the power of n minus 1. So in these problems where you're given a common ratio and a sub 1 in a geometric sequence, like this is here, all we need to do is start with the nth term, the formula for the nth term of a geometric sequence, and plug in 4 for r and 6 for a, and we get the explicit formula. So let's go ahead and practice that here. Write the explicit formula for both of these problems. You can see here that what we're doing is we're adding 16 to the previous term. So this here is a arithmetic sequence. We're given a sub 1, and so what we need to do here to find the explicit formula is we are going to substitute into this formula for the nth term of an arithmetic sequence. So let me go ahead and write that down here. It's a sub n is equal to a sub 1 plus n minus 1 times d. So I'm going to go ahead and substitute in 4 for a sub 1, and we could see here in our formula that d is 16. So let's go ahead and write comma d is equal to 16. So if we go ahead and substitute in a sub 1 here and d here, what we get is a sub n is equal to 4 plus 16 times n minus 1. I'll distribute out the 16, and I'll be left with 4 plus 16n minus 16. I'm going to combine my like terms here, and I'm going to be left with 16n minus 12. So a sub n is equal to 16n minus 12, and that is my explicit formula for this arithmetic sequence. Okay. And I'm over here now, and you could see that this formula is the formula for a geometric sequence. Right? And how do I know that? Because we're multiplying each previous term by 4 in order to get the next term. So this here is a geometric sequence. And we can also see that our r in this case is 4. Right? So I'm going to put a comma here and say r is equal to 4. Common ratio. Every previous term is being multiplied by 4 to get the next term. So now that I have that, well, what I'm going to start with is my formula for the nth term of a geometric sequence. So it's going to be a sub n is equal to a sub 1 times r to the n minus 1. I have my a sub 1 is 22, and I have my r, it's 4. So a sub n is going to equal to 22 times 4 to the power of n minus 1. And this here is my explicit formula that will give me any term that I want. All I need to do is plug in a value for n. Okay? So I'm going to put a box around this.